which is this, but I don't have y prime. Can anyone dictate y prime? E to Rx times? Very good, times the inner function prime. Awesome. Can anyone give us y double prime? R is the constant, will stay outside. E to Rx times R. Excellent. Not too bad. Not too bad at all. Now let's put everything we have in the differential equation. So, can anyone dictate the first step? What do I replace y double prime by? R squared e to Rx minus 4. This will be R times e to Rx plus e to Rx equals 0. Do we agree with this? I replace the second derivative. I replace the first derivative times 4. Here's the first derivative times 4. And I replace the function in here. Yes, please.
Y double prime, you put the R in front of the E because of the power?
Because of a constant stays outside.
Okay.
Yes. Better? I think I saw another. Yes, please.
I don't understand how you go from the y double prime to that.
Yeah, the function, the equation is here. I'm just filling it in.
So how would you get r squared from that?
R times R. Good, so now you know, since you know me already, what do you think I'm going to do next? Of course, e to Rx, and what is left in parentheses? Yes? 4R plus? Exactly. E to Rx will never be 0. Ever. For any power other than in negative infinity. So this will never be 0. So the only option is that this is 0. Not factorable, so I will have to use the quadratic formula. So can anyone give us the quadratic formula? Negative b plus or minus b squared minus 4ac over 2a. So then r equals 4 plus or minus the square root of 12. Good. And I will write the square root of 12 as the square root of 4 and 3. So 2 the square root of 3 divided by 2. Do not simplify in a sum. You can separate 4 over 2 plus or minus 2 the square root of 3 over 2. And you simplify like this. That's allowed. 2 plus or minus the square root of 3. So the question was, one more time, for what values of r does this function given to us satisfy the differential equation? For two possible values of r, 2 plus the square root of 3 or 2 minus the square root of 3, this function will be a solution of this differential equation. It's definitely satisfied by it. Okay. Moving on. The next section, 3.5. Any questions for me, please? Any questions before we move on? 3.5, implicit differentiation. Yes. Okay, so if I'm giving you the function, like for example, in the previous example we just looked at, was e to Rx. The function was given to us. We're asked to find the rate of change. We're asked to find the derivative. That will be done directly. Straightforward, directly. So I determine y prime directly. However, if I have an example like the following, number 12, on page 215, which is cosine, in parentheses xy equals 1 plus sine y, I'm going to ask you, please solve for y. No one can by hand. No one. A Maple software or Mathematica or MATLAB, yes, they will. but no human can solve this for y. However, we're asked to find dy over dx, which is y prime. Same thing. Whenever we talk about implicit differentiation, this is not the best notation for the derivative. I'm not going to use it. Can you? Yes. Will you get the same answer? Yes. But it's not a good idea. We're going to use this notation. So we can still find an expression for the derivative. How? Implicitly, not directly. We're not given the function. No one can solve for the function y. But we can still find the formula for dy over dx implicitly because we don't have the function. How do we do this? Do you remember that we can, in an equation, add 5 to both sides? Take the square root from both sides? What do you think I'm going to do now to both sides? Because I'm trying to find this. Differentiate. Not yet. We are not integrating yet. Okay, so we are differentiating the left-hand side, and we are differentiating the right-hand side. This is not an easy situation. You will see in a moment why. Slowly, let's differentiate the left-hand side. How many functions are there? Let's go this time from the outer to the inner. Cosine is the outer. But the problem is that inside we have a product. And I have to use the product rule. That's one thing. Secondly, y is not a variable. If I'm told to find dy over dx, I'm specifically told that y is a function of course, y is a function of x. You can write it if you need to. Y is a function of x, comma, to be specific, not a variable. It cannot be treated as a variable. It has to be treated as a function. Ready? So, I'm going to write 1, and I'm going to write 2. Okay. When I differentiate cosine, we get negative sine of the same argument times the inner function prime. But the inner function prime must be a sum. Why must be a sum? It must be a sum because this is function 1 times function 2. 1 prime times 2 plus 1 times 2 prime. So that's the formula. That's what I have to have in here. 1 prime times 2 plus 1 times 2 prime. If you're using this order. I recommend it, but if you're used to something else, I'm fine too. Okay, so I have to differentiate the first function, which is x. Well, I get 1. So I'm multiplying. So if you want, you can write 1 just to see it. Plus x times the second function prime. Yes, but I have to write dy over dx. Indeed, it is y prime. We are done with the left-hand side. Can anyone give us the right-hand side now? The derivative of 1. Good. The derivative of sine. Careful. This is just cosine y times the inner function prime. Excellent. Okay. Is it done? No. Here's what I am after. I am after this piece. I will have to solve this equation for this piece. Not before I distribute negative sine xy to this term and to this term. To eliminate brackets first. So the first term would be negative y sine xy. And the second term will be negative x sine xy in parentheses times dy over dx equals cosine y times dy over dx. I don't know how I made it in one row, but I did this time. Yes, please, Vanessa.
I see how you got those first 3 terms.
Yes.
But what about the 1? Do you not copy the negative sign xy again? Or
You mean the right-hand side?
the left-hand side? I'm not sure how you can just re-look at how you got.
Yes. So cosine prime is the outer,
Yeah.
and this is the inner. So cosine prime is negative sine of this,
Yeah.
times the inner function prime, which is here.
Yeah, how did you get the bottom one? I know you got that one, but.
There's only two in the bracket.
Oh, wait, yeah.
Because X is
There's only one in, okay, I got
confused.
No, I was just showing that in brackets I have to use this formula.
Yeah, I thought there was another multiplication in there.
No, no, no. No, so this is 1. The first function prime is 1 times the second plus the first function times the second function prime.
Yeah.
Better?
Yeah.
Perfect. Okay, so now remember we are after this. I'm going to move this entire term to the other side, factoring out what? What is common? X, no. This is common. xy plus cosine y times dy over dx. So I brought a negative term to the other side, it became positive. I copied what is in front of dy over dx from that term and from this term, and I pulled out dy over dx. And now this is the final step in which I solve for dy over dx. Can anyone dictate, other than Emily, Harvey, anyone else? And Chris here. Does anyone else who hasn't said anything today? And you know me, I don't put a spot on anyone. So if anyone else wants to.
You just divide it.
I divide both sides by what's in parentheses in front of dy over dx. Excellent. So I'll put minus in front. Y sine xy over x sine xy plus cosine y. As I said from the very beginning, was not a friendly function for a friendly equation at all. And now I would like to practice. That's how we get derivatives of functions that we don't have. Ready? Do I get to choose or you want to choose? 28 on page 215. So in 28 we have, this is a easier situation. We have x squared plus 2xy minus y squared plus x equals 2. They are giving us a point, 1, 2, and let's see what the question is asking. Use implicit differentiation to find an equation of the tangent line to the curve at the given point. So this time, I could solve for y. I can't using the quadratic formula. It's going to be super messy. I don't even want to think about it. But this time I can solve for y. I don't want to because I don't care for y. I care for y prime to plug in 1 to get the slope and then find the equation. That's all I care about. So in that case, what will I do to both sides? Good, so let's differentiate both sides. Please remember, if you need to write it, please write it. Y is a function of x, not to be treated as a variable. So then the left-hand side, can anyone dictate? Awesome. Plus, now be very careful, 2 stays outside, but this is again a product. Function 1, function 2. Careful. In parentheses, x prime is 1 times y plus x times, excellent, minus. Now again I have to be very careful because now I have a function raised to the second power. How do I differentiate a function raised to the second power? I bring down the power, I multiply by the function, I subtract 1 from the power, and times the inner function prime, dy over dx, plus x prime, that's easy, but that's the variable. plus 1 equals the derivative of 2.
0.
Excellent. I have to distribute, and then I'm after dy over dx like I was a minute ago. Okay, so 2x plus 2y plus 2x dy over dx minus 2y dy over dx plus 1 equals 0. I'm after this and this. I will factor out 2x minus y in parentheses dy over dx. I'll get rid of everything else, moving it to the other side. Negative 2x plus 2y plus 1. Yes, Vanessa?
The last line.
This one?
The very last line. The left side.
Here?
The left side of it, yeah.
This one? Okay, so I have 2x and 2y. I pulled out a 2, so it's x minus y in parentheses, and dy over dx is also out, being common. So therefore, dy over dx equals negative outside 2x plus 2y plus 1 over 2x minus y. Now, if you say this to me, I will have no argument. If you say, okay, you worked on all this, you got a formula for or an expression for dy over dx, but you still have y in it. I have no choice. But that's okay. So I didn't get a clean, and I can't get a clean derivative without y in it. I don't have y. But that's okay. Remember the point was 1, 2, which means when x is, exactly, when x is 1, y is 2, because I need this number. This, it will be the slope of the tangent line that I'm going to create in a minute. So I plug in 1 and 2, 1 and 2, and get the number. So 1 and 2, that's 4, 6, 7, I think, at the top with negative in front. And 1 and 2, this will be negative 2. Correct me if I'm wrong. Did you all get 7/2? So 4, 2, 6, 7, I think it's correct. 1 minus 2, negative 1 times 2, I think it's 7/2. So if you all agree with this, then I have y minus y1 equals the slope times x minus x1, where I have 1, 2, and 7/2. 1 is x1, 2 is y1, and the slope is 7/2. All I have to do is distribute, solve for y. So y minus 2, 7/2 x minus 1, 7/2 x minus 7/2 and plus 2. I have to move 2 to the other side. So here I have to combine, so I have 4, negative 7 minus plus 4 is negative 3/2. So y equals 7/2 x minus 3/2. Can anyone tell us what this represents? The equation of the line, tangent line to whatever was given to us at the point 1, 2. Excellent. Well done. Any questions? Yes, Ricky, go ahead. Yes.
So how did you get y, like in 2x plus 2 is parentheses y plus x? Is it
You mean here?
Which one?
Oh, because the first function prime is 1. The product rule. The product rule. The first function prime.
So like if both of them
prime times y plus x times y.
so if it's x times y is y.
Because x prime is 1.
But if it's just y,
Because it's just y alone,
then it's the
dy over dx.
Oh,
Because
okay.
we don't have y. Yes.
But if it's multiplied by another variable, then we have to use product.
Every time you have two different, yes, you have to use the product rule, the two different functions. Other questions for me on this problem? Okay. We have other things to worry about in this section. I have roughly 10 minutes left. So I would like to show you one more concept from section 3.6. I do not consider 3.5 finished at all. I still have to go for other concepts. But I would like us to just talk about one concept in 3.6, and we'll come back. Logarithmic differentiation. Logarithmic differentiation. So we have direct differentiation, we have implicit differentiation, and now logarithmic differentiation. What is that all about? Here is the reason why we need this. So we know how to differentiate a function raised to a power, right? We know that this derivative is n times f to n minus 1 times f prime. We know that. We also know how to differentiate a constant raised to a function, prime. And that is a to u times u prime times. Excellent. Okay. Now, here's the third situation. A function raised to another function, prime. Yes, I'm going to give an example right now. Sine x raised to cosine x. And we want to differentiate. This is a situation like this one. What do you think? Just a wild guess. I know it will be wild. What do you think? Just any idea. It doesn't exist. There is no formula for this. So then how do we differentiate? Here's how we differentiate. So let's look at this example. Y equals sine x raised to cosine x. We are going to apply natural log to both sides. So if I say to you, two numbers are equal, 2 equals 2, then natural log of 2 equals natural log of 2. If I say to you x equals 2, then I can apply log to this side, and I can apply log to this side, like we differentiated. We had an equation, this equals this. The derivative of this has to equal the derivative of this. The other side, same thing here. We are told y is sine raised to cosine, then natural log of y must be the same with natural log of the other side. But what can I do furthermore to this side? There is a property that only log has. Which property am I referring to? Here's the property. Natural log or any log, let's put any log, base a, of x raised to the nth power. This is n times log base a of x. This is not differentiation or anything. This is just the property of the log function. Whenever we apply log to a power, the power goes in front as a factor. It has nothing to do with differentiation. So I hope you remember this property. This is not the change of base formula. That's a different story. Okay, so then what do you think I'm going to do to the right-hand side in lieu of this? Very good. Cosine x times natural log. Very good. Awesome. Okay. Now what do you think I'm going to do to both sides? Of course. The left-hand side prime, the right-hand side prime. Ready? I will show next time why natural log of x prime equals 1 over x. I'll show you that. What do you think about natural log of a function prime? What will that equal to? 1 over u of x times, of course. Now you know the rule. Perfect. So the left-hand side. So let's start. We will prove this, why this is it, like we did with a to the x. I will not ask you for it, but I will show you why. The left-hand side, what will you write? 1 over y is this piece, because y is a function, times very good. The right-hand side, let me caution you, this is a product of two functions. Cosine prime. That's the second one is with a negative, right? The second function. The cosine is with positive, okay? Times natural log of sine x plus cosine x times, I have this formula one more time. Natural log of sine x will be 1 over sine x times, which is? Very good. So here we used both logarithmic differentiation and implicit differentiation. Good, so let's clean it up. It's not done. I am after, yes, Vanessa?
Isn't cosine x prime, isn't that negative cosine?
No. Sine, so sine prime is cosine and cosine is negative sine. But when we different, oh, I wrote cosine, yes.
Yeah.
I'm sorry. I did write. Thank you. Thank you, my apologies. I did write sine. So cosine prime is negative sine times natural log plus cosine times natural log prime, 1 over sine times cosine. Perfect, thank you, my apologies. So now I'm asked after dy over dx, bless you. I will multiply both sides by y, but y is the function itself, sine x raised to cosine x. Everything else goes in brackets. Negative sine x natural log sine x. I'm going to combine these two into cosine squared over sine x.